Hello and welcome to my channel, and in this video we're going to be looking at the differences between common table expressions, CTEs and derived tables. I have created some sample data that I'm going to be using in this video, and if you would like to follow along, it is available in the description below. Let's dive right into it. So I've got a simple query here that's going to just select some data from a table. And if we have a look at that data, we can see that there are some duplicates in the table. So the first thing we want to do with this data is clean it, is remove those duplicates. I'm keeping this as simple as possible. I'm not going to be using any string manipulation or data type conversions within the cleaning data stage. It is just going to be simply removing duplicates. We're then going to aggregate that data by customer and month. And then we're going to take that aggregate data and join it back to some details that we need to return within our query. If you're not familiar with derived tables or CTEs, you will see some cards in the top right hand corner of the video with some links to other videos on my channels, and I'd recommend you go and watch those first before checking this out. One of the other major differences between CTEs and derived tables is CTEs can be recursive. They are very good for resolving things like parent-child hierarchies within a database efficiently. And we're not going to talk too much about that, but again, a link to the video will be available. So derived tables and CTEs are both table expressions. And it's an understandable question amongst people who are starting to work with these types of operations in SQL is what is the difference and when should I use one or the other? Well, we have derived tables which are declared within the from clause of a query, very similar syntax to what we have with subqueries, and we'll go through some examples shortly. And then we have CTEs which are declared at the top of a query, and then we effectively query that declaration of a CTE. So let's start off with a very simple example where we're going to look to remove the duplicates from this data. So to do that, all I'm simply going to do is drop a distinct into this query, and then to turn that into a derived table, I'm just going to hide the results grid from now. I'm just going to write a select all from. I'm going to open my parentheses. Now the inner queries I always like to indent depending on the level, and then I'm just going to give that an alias as clean. And there we start with a very simple derived table. That is a derived table in its simplest form. So we have an inner query, we give it an alias, and then we're selecting from that query. Let's have a look at the equivalent within a CTE on a new query window. So if I was to do exactly the same, again I want the same result, so I'm going to add distinct, and I'm going to put that with, so CTEs always start with, and I'm going to give that a name, in this case same name as clean, and then again I'm going to put the inner query within parentheses, close those parentheses, and then the next stage is to do a select from the name of the CTE. So if we execute that query, we can see we get exactly the same results, but it's done in slightly different fashion. Now for both, we are able to execute the inner query independently for both CTEs and derived tables. And we can see here one of the major differences, and this is why one of the issues with derived tables that CTEs came along to address is readability. So because we have to build the derived table or create the derived table within the from clause, and we'll see this as we go further into the operations we perform on this data. It's decided it's not as human readable as it could be. So that is one of the main issues that CTEs were brought along to address, was readability. So we have here almost an independent declaration so we can see top to bottom what's happening to the data. Let's make that a bit more apparent, and let's add in a next level. So the next level is we're going to aggregate the data. Now, CTEs and derived tables are, in terms of performance, are functionally equivalent. So what the database engine is going to do is when we write its query, it's going to move everything in line. So what that means is it's not creating this table, it's not creating distinct copies of these rows into a table and then referring back to it. It's taking the query rewrite as a whole and just folding that out and evaluating that. So what we want to do from this data is we're going to group by customer, we're going to group by month, use the month function, and we'll give that an alias as MNTH, and then we're going to do a sum on the amount column and we'll alias that as total, and then we're just going to group by customer and month. So that's more representative of what we typically do within a derived table or a CTE. We'd perform an operation on the data and then take that, the result of that, the table expression, and perform another operation on the data. So that's where CTEs and derived tables both come in, is where we need to perform multiple operations on the data. So I'll just add the equivalent for the CTE. Now I don't have anything going across years in the data. Like I say, I'm keeping it simple, and that's why we can just use the month rather than having to look at the years. It's the data is across the same years. Group by. So again, we get exactly the same results. So what you want to be asking yourself at this point is which one is more readable. And as we go further, you might see that CTEs actually become maybe a bit easier to work with. But the last thing I want is for you to go away from this video and constantly just use CTEs all over the place. Derived tables still have their purpose. I still use both. In this example, I'd probably typically use a derived table because for me, I think it's easier to work with. But when we get into further levels of nesting, or the example we're going to go through at the end where we refer back to the same table expression multiple times, you'll see the benefits of CTEs. So if we take this data now and say we want to add some detail to it, so we're going to nest another level. So that aggregate is going to be another derived table built on a derived table. So this is called nesting. So if we take what we want to return is customer, month. We also want to return customer type. So we're taking this aggregate data and we want to return some details. But we need to remember that we haven't cleaned the data within a table, so we need to join to another version of the table. So we're going to be taking this derived table, this nested derived table, and joining to another derived table. So we want start date, we want month, and then we want total, and we want that from. And again, I'm going to add a layer of indentation to represent an inner query. I'm going to alias that as aggra. So we're taking aggra and we want to inner join to another derived table, which is almost going to be exactly the same as what we did here, but we want to take out, let's just align this a bit better. So we want customer, we don't want location, we don't want date and amount, we just want to return those unique values, and we'll alias that as detail. We'll give these the aliases. That's coming from aggra, that's coming from detail, that's coming from detail, aggra, and aggra. And if you can't see these queries great on screen, I will add these again into the description below, so you can copy and paste those into a query window or simply a notepad file just to have a look at them. So we're going to be joining to detail on customer. So if we go ahead and run this query now, so we can see we've got the results. So we've got each customer, we've got a couple of customers that go across months, and that's why we've got duplicate rows for them. The query results is really not what we're looking at here. So to get this just on the one screen, I'm just going to zoom down to 70%. So as we can see, that's our final derived table query. So we've got a couple of nesting levels of derived tables, and we've also got a derived table that we're then joining that other derived table to. So there is a lot going on in this query, but you can see from a complexity point of view, if you was to come and see this within a query or a stored procedure, there's a lot of complexity going on there. You'd have to, functionally you start here and you have to have a look at what happens to that data again. And I've definitely seen a lot more nesting levels than 3 in some queries. One of the major benefits of derived tables though over CTEs is the more levels you nest, the more you can keep querying very easily. So we can execute the most in a query, and then we can execute the sort of outer inner query, if you'd like to call it that, very, very easily to see how that data builds up. Let's have a look at what that would look like in terms of a CTE. So what we do here is we're actually going to be declaring another CTE. So we just add a comma, and then this is going to be aggra, and we are going to indent this, as I like to do. I'll just get rid of that semicolon for now, and then we can have select all from aggra. So run everything. So there's our aggregates. So this is the difference I was just mentioning with CTEs. So it's very easy to run the first one. However, if we want to run the second one, we've got a couple of options. One option is we comment this bit out. We would actually need to leave that comma in there. So we could run that, or we just need to keep changing the select statement as we've done there. So we can refer to clean if we wanted. So even if it's processing the aggra CTE, we don't actually have to return data from that. Okay, so we've got our aggra. We then want to do a join back to the details. So again, we could have another CTE here as detail, and that would be almost like clean, and take out location. We're just taking out some columns here that would cause further duplicates, like a one-to-many join, and then we can select all from aggra as a inner join detail as B on A customer equals B customer, and then from A we want A customer. I'll just increase the size of this. A customer, and we wanted B customer type, B start date, A month, and A total. If we execute the whole thing, we get the same results as the derived table, but does that look a bit cleaner and more readable to yourself? And that's the question you need to ask when you're looking at nesting multiple levels. We can see at a top level if we just wanted to perform one operation. So typical example is we're going to group by and then join back to the table. If we needed to do that, it would be, I think, to be honest, down to personal preference whether you like derived tables or CTEs. Like I say, I use a mixture of both, and you can combine derived tables and CTEs here. So if we took out the detail level, we could actually say, we could actually put a derived table here. It should be customer type, start date, yep, that's exactly the same results. So there's one way of combining CTEs and derived tables. So I bet you're hoping from this video you're like, what do I need to use? And the answer is always it depends, but I would try out both. You can see the benefit of CTEs. We're looking at declaring something at the top or working through that data, rather than here where we've got, okay, this query, when I look at this query as a whole, this query is executed first, then that query, then that query. Whereas here you can see, okay, this is what happens to the data, then this happens to the data, then we get this. So it depends on how you look at the data. Nesting derived tables can get quite complex, so it just depends on how many operations you'll need to perform on the table. Like I say, I don't want you to go away and just think I can use CTEs for everything or derived tables for everything. You can, that is an option, but have a go with both. Now the other thing we can move on to, and the other major benefit of CTEs, so the first being readability of CTEs. The second is actually when we need to refer to the same CTE or derived table multiple times. So we'll go through another example of that now, and I'm going to shortcut the process just to make that simpler. So I'm just going to drop this data into a table for us to, so I'll just create a customer sales clean version. Shouldn't have that there. So I'll just have a quick look at what that data looks like. Should be a lower row count. Yeah, cool. So let's take that onto a couple of new query windows, and let's work through an example of, let's say we want to compute the let's say we want to do the month-on-month comparison for customers. So what we want to do here is customer, again we're going to use our month, so pretty similar, well pretty much exactly the same as the way we aggregated the data before. We're just not messing around with our cleaning stage, because we've dropped that into another table, or our deduplicating stage, some amount as total. So let's say we want to add in the group by. Let's say we want a way of, if we have a look at Paul Kirkland here, we can see he spent money in month 5 and month 6. So let's say we want to do a comparison between both months. So how we do that within a derived table, we want to write out a month-on-month comparison. And this should really show off some readability differences. Is what we're going to have to do is we're going to do a select from, and this is how we're going to build out this query. I'm going to indent this as previous, if I can spell previous, and then I'm going to left out a join exactly the same data. It should become clear why I'm doing this very shortly, and that's going to be as current. That's going to be on previous customer equals current customer, and previous -1 equals, sorry, previous month -1 equals current. So if we have a look at and then we go so customer will be both in same in both tables, and then we go current, so total minus previous total, that's difference, and if we have a look at that, so we've only got 2 customers that spent money in both months, but what we can see here is we're having to write the same query out multiple times. So within a derived table, you can only refer to that table that you've declared once, whereas we'll see the functional equivalent with CTEs, and it's much less verbose. So if we write out the equivalent of that within a common table expression, so we wanted aggregate as select customer, month, date as MONTH, and then some amount as total. Add in our group by customer and month, and then we can do select all from aggregate as A, left out to join aggra as B, and we'll just alias those better as we've done within the derived table previous. So you can see here I'm actually referring to the same CTE multiple times, which I couldn't when I was working with the derived table. That'll be on previous customer, current customer, and previous month equals current.mnth. I'm going to select current.customer and then current.total minus previous.total. Okay, and we get exactly the same results, and we can see there another benefit of CTEs over derived tables is that we can refer to the same reference multiple times. Yeah, and we can see that's a much succinct piece of code there. It's a lot less verbose, there's a lot less going on, it's easier to tell than when we look at the equivalent within derived tables. There's a lot more going on there. We have to effectively run the same data against the same table twice. Now that doesn't mean within CTEs that it's going to, again, it doesn't save this result. So we're not going to see any performance benefit really on that unless that result starts to be saved. But it is just easier for the eye to see. So the two major benefits of CTEs over derived tables are readability and ability to refer to the same reference multiple times. The benefit of derived tables over the CTEs, if we look back at that previous example, is it's easier to keep building on top of derived tables and having a look what's happened with the data. If we have a look at that within CTEs, so it's easier to look at the first layer. If we wanted to look at the second layer, we'd have to actually comment this out here or change our select to see how that data is flowing through the CTE. So you don't always get a clear visibility of what that data looks like at each stage of processing effectively within the expressions. So to answer the question really, what should I use, derived tables or CTEs? Well, CTEs are more modern. Like I say, they were invented to address the problems of derived tables. So in general, you'd probably be better off using CTEs, but I wouldn't dismiss derived tables altogether for simple things, or you may just prefer that approach. Like I say, there's very little in terms of performance between the two. They're both executed in exactly the same way. Let me know your thoughts in the comments below. Subscribe to the channel if you haven't already. Thanks a lot for watching.